Hello, everyone. I decided to throw my hat into the ring and make this math video for YouTube because I've been watching a lot of YouTube math celebrities, YouTuber mathematicians, and so on go through so many loops, through so many long and boring steps in order to explain things in painful detail. And as an engineer, it hurts me a lot to have to spend so much time and skipping so many parts of a video just to get to what I want. So I wanted to introduce a very common engineering shortcut to integration by parts and more specifically to the substitutions needed for it. So anyway, let's begin. Now remember, this method has been used for decades. I don't remember who started it, but it is a very, very useful method for shortening the number of steps needed. And we're going to apply this shortcut on yet another popular integral that's been making the rounds on YouTube and people are getting invested in. Now, I'm not going to show all the steps for every single part because, again, those are things that you can find on YouTube that I've noticed other people go through painstakingly long explanations to get, but I will provide the sources in the description. So anyway, the integral is from 0 to pi by 2 of x divided by tan of x dx. So for us to start playing around with this shorthand substitution method, I'm going to split the tan x into its original form, sine x by cosine x. And since tan x is in the denominator, we're going to end up with the expression of x multiplied by cosine x over sine x in the integral. Now, the shorthand substitution is as follows. Instead of declaring a brand new variable and finding new bounds for the integral, we're just going to pop that little cosine x into the differential at the end of the integral expression. And we are going to simply rewrite that differential as a new differential based on the little mini integral that we just performed right now. A little mini integration. And if you don't want to get confused, you can ignore the limits of the integral, the bounds, and just treat it as an antiderivative until you are completely done. Then substitute everything back at the end. Remember, you are not substituting variables. You are just substituting the limits of the integral. If you're done with the integral, then your final integral function can take those exact same limits because you did not use any algebraic substitutions. Anyway, we now have the new expression of the integral of x over sine of x with respect to the differential sine of x. Now, recall that the derivative of a natural logarithm of a function, henceforth is going to be called ln of a function, is simply 1 over that function. So if you see a differential of a function over a function, then another little mini integral you can do is the ln of that function. And that's exactly what we're going to do here, precisely that. So we have the d sine x over sine x is going to become d of ln of sine x, because we integrated 1 over sine x with respect to sine x. And the x is going to be remaining on the outside of the differential. Now, integration by parts is simply the switching around of these two parts of the integral, subtracted from the product of the two parts of the integral. In this case, the two parts are the x remaining on the outside of the differential and the ln of sine x on the inside. You can multiply those two very easily so that you don't forget or get confused by how to integrate by parts and get x ln of sine x as the first part of the completed integral function. And you can substitute from 0 to pi by 2 again. And this limit can be taken at 0 to equal 0. And if you substitute pi by 2 for that part, you get 0 as well. So that entire expression is gone. And you're left with negative of the integral of ln of sine x dx. Now, the way we got that is simply that we switched around the x and the ln of sine x so that the x is on the outside and the ln of sine x is on the inside of the differential. If you switch those around, you get ln of sine x on the outside and dx on the inside. Your long integration by parts usually tells you it's basically u dv is equal to uv minus v du. Well, we skipped that as a direct consequence of our shorthand substitution as well. Instead, we just do it by inspection. You end up with the integral, or the negative of the integral of ln of sine x dx from 0 to pi by 2, which again you can look up, and you will find that the result of that integral by itself is equal to negative pi by 2 ln of 2. And since we had a negative on the outside, the two negatives cancel, and you end up with the final result of pi by 2 ln of 2 as your final answer. And that, ladies and gentlemen, is the shorthand, simple way of integration by parts and substitution. Thank you very much, and I will see you in the next video.